Hi guys, we're going to have some fun with this today. This is from a Range Rover P38. Many of you that know me will be very well familiar with these things. And what we're going to do is we're going to have a quick tear into this. I've just noticed a problem already. And normally I want to check this one out, make sure this one's good. This is one out of my vehicle which was replaced because all the bulbs had failed on this. And we're going to have a look at what we need to do to chuck LEDs in this one. So bear with me, I'll go get some tools. Let's get inside. You've got 1, 2, 3, 4, 5, 6 screws in the bottom. We'll just get those out. Try and not lose all of them. These are well known. If you or anyone you know has a Range Rover P38, then you will be most likely very familiar with these things. They are one of the biggest source of pains to Land Rover ownerships in existence. Let's just grab that one out of there. There we go. They are renowned for failures. They're not the most resilient bits of kit. I don't know that they're made by Lucas. They may well be. But other than the fact that the bulbs go, which give you problems, all sorts of issues with them, they're also electronically not that robust either. So bulb wise, if you're just doing bulb replacement, you don't actually need to crack this off. It may make your life a little bit easier because that cover there just covers the end of those bulbs. You can get them out without taking it off, but it's handy to take it off. If you're just changing the bulbs, there's one there, one there, one there, and one there. They're all the same type. Actually, that's not a bulb. And then there's a different type here, which, as you can see in this one, is missing. Bulbs come out easy enough. Screwdriver in the back or a pair of pliers, and just lift them out, and they're the standard sort of dashboard bulbs. I can't give you a rating on that one because it's not there. We'll pop that one out. No, it's gone on that one. I think they're 12 volt 2 watts. I'm not 100% sure. No, there's nothing. Oh, there we go. 12 volt 1.2 watts. You can buy them from Halfords or anywhere like that. I don't have the cap to the other one that's out. I thought it might have been on my bench, but yeah, there it is. So the one that's out is a 12 volt 2 watt. You can see it's on a little green base. Now, there's two ways of doing this. You could solder the LED and the resistor for the LED in here. The trouble is you need to remember which way round it goes. They'll only work one way round, unlike the bulbs, which will work both ways. The way that we've done it before is to actually solder directly onto here. So what we're going to do now is we're going to take this cover off here, which pretty much involves taking the front panel off. If you're going to do this, make sure you where it's clean, where you can organise everything, because all the buttons are going to fall out shortly. Let's just take these ones out around the front. If you're going to do this, it's actually a really good time to get in here and have a really good clean. You can get in behind the switches, you can get in around the displays and just get everything absolutely perfectly clean. These are fragile enough that I would say don't do it for the hell of it. There are better ways of getting them clean, getting into the edges of the display. Don't take one of these apart just for the sake of cleaning it, because you're going to land yourself in a world of hurt. It's not made by Lucas, it's made by Valio, which probably explains quite a lot. Right, all the screws are out and we just lift off now. And then there is a ribbon just in here which you can lift out like that. And you separated the two. I couldn't remember if the whole lot came apart in one hit or not. Now everything we're interested in is actually on this board. I was convinced that that was a bulb, and I'm still not convinced that it's not. So we can have a quick look in here. We'll have a quick look at this board as well. We're still retained somewhere, I think. Nope, we're out. Put that to one side. So this is your main board. This is the cause of a lot of the faults where you replace the blend motors and nothing changes. So you're going to want to look around here for signs of water ingress and nastiness. Check the joints on these. You've got 2 voltage regulators here, they need to be good. And I'm not 100% sure what those are. We can have a quick look. I'm guessing, given the number of them, they might be servo drivers. L272M. They could also be, as quite often is the case in auto electrics, something that's been specially made for Land Rover. There is a lot of specially designed chippery in the P38. Right, okay, it's available. So what is it? We're not got the fastest internet connection in here, but it would appear that it is a dual op amp. Yep, L272M on semiconductor, 350 kilohertz dual op amp. So they'll be used for the part of the servo drivers for the blend motors. I'm just looking around. So here are the power transistors or MOSFETs or whatever they are for the blend motors. 1, 2, 3 there, 1, 2, 3 there, 1, 2 there. So any blend motor silliness where you know that the blend motors are good, you're going to want to check around those. These will then be the comparators and that for the servo side of things. And again, you could just look on the back. This isn't conformally coated, which surprises me. It makes it easy to service, but it means that it's vulnerable to moisture, damp, corrosion. And yes, it's inside the vehicle, but you know, winter comes, you get condensation on the inside of the vehicle, you'll get the liability that condensation will form on the heat sinks as well. So really, that should be conformal coated. Conformal coating also protects against vibration. Other thing to check in here, same old on any electronics. You've got electrolytic capacitors here. Let me just zoom up a bit for you, assuming I can. Bear with me. Just takes me a few seconds to get where I need to get. I closed everything down. And now I can't spell either. Right, so let's zoom in a bit and focus. Yes, no, maybe. There we go. Right, so quick recap again. Now I'm zoomed in a bit more. You've got these, which are your the op amps that will do the servos for the blend motors, and then these devices here will be the power transistors to drive the blend motors themselves. What we have in here, that's a voltage regulator, that's a voltage regulator. Not sure about that one. And not sure about that one either. I think, if memory serves me correct, this is the same power MOSFET that's used in the BECM. So this is possibly the outputs. No, there'd be two of them. This may be driving the fan relays. So that might be worth a check. You've got 1, 2, 3, 4 electrolytics in here. As we know from other things, TVs and that, electrolytics do have a habit of going. I'm looking at this one in here. If you can't quite see, it's a little bit wonky on the board. So yeah, that might not be great. That's not wonderful. That's stood up in the air. That could really do with some hot snot on it. It happens that I've got the gun here. I know there is no fault with this, so I'm going to hot snot that down now. The idea is if you look in there now, once that dries and sets, there we go. I've got one of those as well. Come here. That will give that a little bit more mechanical support. But yeah, that's your logic board. That probably, I can't say without trying it, is probably going to be interchangeable with the display board here. So you may find that if you've got a good display but a bad logic board, you will be able to change that over. Things like blend motors not working, fan relays not kicking in, that could all in theory be this. There's no sign of any fuses on there. There's a couple of MOVs and there's nothing in here that looks like it's gotten hot. So that all looks good. We'll put that one to one side now and we'll come back to this one. I think I'll leave you zoomed in. Right, this is where all the buttons and things go everywhere. This is the front panel board. So this is responsible for all of the LEDs behind the buttons, the LCD display itself. Some of these do develop problems with some of the buttons not working that well. I'll show you how to fix that. And it's also where we can make a good check on what the voltages we need actually are for the LEDs and see what's going on back here. If you get segments out on these, I believe this is a zebra strip used on the display for this. I'm also seeing another potential problem. So down here we have another little electrolytic capacitor that should be sat down, but it wasn't. So we don't like that. So once again, dollop a hot snot on that, just to keep that there. Right, if you're doing this yourself, face down on the table, and I believe it pulls up. I might be wrong. One moment please, rather than let you watch me figure this out, I shall pause this for a second. Sometimes it really is just that simple. We missed a screw. So we can lift this board out. Again, if you're doing this, make sure you've got it on a good surface and just lift this board straight out. And be careful of the zebra strip that it displays on. You can see that that display is properly filthy, and obviously when this display is in you can only clean up to the bezel, but if you're careful now you can clean the whole thing. Just pop that to one side and just show you what we've got in here. So each one of those LEDs sits in one of these light pipes, and then these light pipes, if I just pop one out, distribute the light along behind the buttons. You can't change the colours here. These are all green filters, so you can't really change the LED colours. You've got the same on here. You've got these light pipes. This is the up and down buttons, the hot and cold buttons for the climate control, and they just sit in like that. And then you've got this one here. There is actually another bulb in there, which I don't think is particularly removable. We'll look at that in a minute, but that will be your heater knob and these controls. So each one of these bulbs does a particular item. You have the bulb in there which does that, you have the bulb in there which does those two, and you have these two which do this. So if you've got a particular area of the display or screen that's gone out, then that's it. If you then gently grab hold of this here, you can actually lift this section out. Again, it's a chance to get in, get all the gunge out from under there. If you turn any of this upside down, the buttons are going to fall out. But there you can see there's ample chance to get in there and clean things out. So we will drop that back in there for now, because we're not interested in that. Well, I'll clean it anyway. Let's pop that to one side again. Hopefully without having a short shower of buttons. And then here we go. This is your button board. Curiously, for some reason, Land Rover put LEDs in. Why they didn't do that for the whole thing, I don't know. So this mat here will gently prise up, he says. Sometimes it's better to just use your fingers. It will just pull up, it will just snap down as well. There are guides on the back of this, there, all the way along, that will help it snap back on. The layout on these is slightly odd. Normally the copper pads that make up the switches are formatted like a labyrinth like that to give you a better chance of bridging the contacts. Obviously in the Land Rover ones you can see they're just semicircles. It would be better to have the E-shaped ones, personal preference. What happens when you press a button is on the back of each of these switches you'll see these little black things. There's one there. These are carbon impregnated, they conduct electricity, and they press down across these terminals. What happens as these get older, or if you've gotten a little bit carried away with cleaning, is the carbon goes. You can buy carbon replacement kits online. They're not particularly cheap, and you can go over these. The one that's in my vehicle at the moment does have a problem with a couple of these. So if you've got dodgy buttons, that's almost certainly the cause. Bad segments on the display. That's going to be this. Now, working around this display, be careful. If you do anything to this strip, they tear quite easily. They disengage from the board or from the display unit itself quite easily. And once that's happened, you're in trouble. Also, when you put this back together, you are going to need everything to be spotlessly clean, because anything that's on this green surface or the back of the display you will see, and it will drive you up the wall. And you can see in there the contacts for the bulb. So we'll just pop that back in there now. I will come back when I'm finished and we'll have a good clean up in here. And then that's your LCD display, and as we can see that's also filthy. There is no location in here if you do want to clean this. Just move that in. You need to make sure that you've got at least one hand on the display so that if it suddenly goes, you're not going to shred this ribbon. Under here, I am stripping this completely. You've got more contacts. This is, I believe, the temperature controls. And then we're almost there. The auto switch for the HVAC, which is in the middle of the button, is there. And then we have this mystery bulb. Now, what do we do to get that out? Okay, that is actually easier to get out than it looks. So we need to squeeze there, squeeze there. There's little tangs on that connector. Pull that mov up out of the way. There's another one there. And according to Sod's Law, the other one has now popped back into position. I'm trying to do this one-handed because I've got hold of the display on the other side. Nearly there. That is a truly horrible piece of design. Let's pop the display back together. There's an a retaining indentation in there, and there's nothing for it to actually engage with. Let's pop that back in. It might be worth, if you're doing this, just put something over there. If you're going to put tape on, you mustn't pull on the surface of this. So if you're going to tape, go down the sides and go with very light adhesive, and then that's that one out. That has no identification, and it doesn't look like it's a holder, or is it? Is it? No. Yes, it is. It's a wedge. And that holder is actually in quite bad shape as well. If it's a wedge, we can pop it back in there. And what have we got here? 12 volts. I think that's a 1 watt again. Right, so we've got this far. We can have a bit of a clean up in here. I'm not going to show this. There's no point. All you would do is clean these up using something along the lines of isopropyl alcohol. Don't use anything overly powerful on here. Obviously anything that attacks plastic is going to destroy the screen. Anything that's going to leave a residue will cause problems with these. So the purest chemicals that you can find to use on here. If you're using isopropyl alcohol, bear in mind that certainly on this one, and probably on most of them, this has been hand soldered. There's a lot of flux on here. If you're washing this with isopropyl alcohol, it will dissolve the flux. Therefore, if you've got it at this angle and you're washing away and clearing up this, that flux is going to get transferred onto the contact ring. That's going to start causing problems with the fan speed not changing on each click. There's a detent in the front panel that gives you the click. So wash it that way. You can, I think, let's just angle that. There's quite a lot of wear on here. Don't go at this with abrasives, just clean it off with a bit of isopropyl alcohol. Same with them. The best thing to use on this is going to be something along the lines of LCD television cleaner or something like that. Right. I'm going to adjust this again because I just do not want this getting damaged. These can be reseated if you do manage to damage one or push one out. That one looks good, so we'll try and keep it that way. What we're going to do is we're going to keep these bowl holders in, and what I want to do is replace the bowls with these. These are top hat LEDs. If you look at them, they're a different shape to most normal LEDs. This will probably not focus properly, but we can try. Focus, focus, focus. Oh, wrong way. Focus, 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 focus. There we go. So you can see they're a slightly different shape to normal LEDs. The idea is that they throw the light a lot wider. If you use normal LEDs, it's not really a problem in these positions around here. But if you use a normal LED behind the screen, what you will find is that you'll end up with a bright dot in the middle of the screen. What I've done, these aren't as bad, but they do still give you that bright dot. So what I've done on the one that I intend putting behind the screen, and I think we need focus again, don't we, is you can see, if I don't go too far, there is a little dot of hot snot on that. What that will do is it will diffuse the light even further. There's other things you can do. Take a Brillo pad to the LED to mist it up a bit. That works as well. LEDs aren't like light bulbs, you'll see that they, if I put it against the back here, we've got two legs here that are different sizes, and if you look on the edge of the case, which you won't see that clearly, there is a flat. The flat is towards the negative side of the circuit, or the ground. Then that's your supply voltage on the other one. We can't give this 12 volts, it will die amusingly and won't be especially useful. So we will be putting a resistor in series, which is one of these, to drop the current down to a sensible level. So there goes that damn display again. Another answer would probably be an elastic band. I can see this not working by the time we've finished. There we go. It's all very well and good me giving you this advice and then not following it myself. What have we got in here? Nothing useful. Okay, we'll carry on being careful. Right. I'm going to zoom out a bit. There we go, just because it makes things a little easier to work with. We need to find the ground tracks on here. The light bulbs are normally wired between the lighting circuit and the ground. Obviously with these that's not going to be the case because these are on all the time. So we need to find a known good ground point and verify that we're all connected together. So let's zoom out just a little bit more. We have a multimeter here. How's that focus looking? Could it be sharper? Yes, it could. Ohms range and continuity. If you've got a meter, they're all different. So what we want to do is quickly just check that this is the case, that these are all connected. Yep. And if we do the other terminals, they should all be the same. Okay, we've got something slightly different going on here. I've got to try and remember how this works. That's correct. Right, okay. So just going back from memory how this works, these... Oh, we haven't checked that one either. That's good. That's good. I would be inclined to put a little dab of solder on that one because it just feels a bit loose. Right, yes. Now, thinking about how it works. The display light is on all the time. These are actually on with the lighting circuit, so that actually makes perfect sense. We need to find a way of identifying the ground on here. I'm going to ignore what's just happened under there again. It's more than likely that the LCD power is always on and comes from the ignition feed to this. We're just looking for something that looks like it might be a ground. Quite often with boards like this you'll have a large ground plane, which this doesn't appear to have. No, there's no ground plane on here that we can easily get to, so we need to work out the ground another way. A good way of doing that, alright, I'm taking that away before it gets lost, is we'll have a quick look, see if we can find this chip. If we can find this chip, we might get the pinouts for it and we should be able to find ground. So that is an M54 82 B7. It's very unlikely it's going to be anything we can identify, to be completely honest. He says completely wrong. It's an LED driver. and we do have a pin out for it. Yep, there we go. Right, so VDD and VSS. Just checking this, you can't see this here. It's always good with things like this that you check your data sheets on 2 different places. Yep, so that's fine. So VSS is our ground. Let's just bring that up. So VDD is there. So we want pin 15. So we start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the other side, 11, 12, 13, 14, 15. That should be our ground. You've just got to love it when a plan comes together. You've got 10 pins, 11, 12, 13, 14, 15. That should definitely be ground. It isn't. Okay. VSS, that won't give us anything either. Right. Okay. I'm doing this so you don't have to, because once I know which one of these is which, you can just take my word for it and save hunting around yourself. So what we're going to do is pair the boards back up again. This is a power board back. We've got a cutout here which matches with the cutout there. Pop that on. This makes it all much easier because we've got regulators here. These 2 here are regulators, and these particular regulators, the tab on the regulator here is always grounded. So everything that beeps now is grounded. And there we go. Right, what we'll do, grab a Sharpie. So that one's grounded. That one's grounded. That one's grounded. That one's grounded. We should be able to find the illumination circuit as well. I'm not actually interested in finding it, I'm just going to have a quick squeeze and see if we can. No. Okay, we're not worried about that, we're not looking for it. Let's take this out of the way again. Right, LED time. I think I don't have enough 1Ks. Right, you don't have to do this next step, but it will make your life easier if you've got it around. This stuff is flux, it's for soldering, we use it for surface mount stuff and that. It acts as a mild acid and takes the oxidization off of these terminals and makes them ever so slightly easier to solder. You can use a light abrasive on the terminals as well, that will have much the same effect. We do need to be careful about heat here though, because obviously this is light plastic, we don't really want to cause problems. And the other thing we want to watch is how deep we're going. So if we put one of these back in, turn it over and see where the head of that bulb is. So the head of the bulb is just level with the board. So we'll take him out again. We want to be a little bit further back because the LEDs don't throw light in quite the same way, but not much. So let's take one of our LEDs. Obviously you want, as I said, mentioned already, you want the short lead. You can use long nose pliers. I'm just used to using these. Pop your LED in for the back, and I'm going to use my finger so that I know this is level. We'll just hold that like that. Let that slide down a bit, and there we go. So that is where we need to be with that. And I think we will zoom down again a bit. Zoom, zoom, zoom. Any of you who haven't lived in North America will now be completely oblivious to that. And those of you that have lived in North America will be cursing me for the rest of the week. Right, bend your LED leg. There we go. So you have the black bit there. And then that's going to sit on there like that. So we need 1, 2, 3 of those, potentially 4. In my case, it's quite handy because the leg bends just above the pip in the wire. 1. And as I said, we're doing negative at the moment, so it's the shorter lead or the one with the flat that you need to be worrying about. And we've got our special one that I made for the display. There we go. Right, we're going to want to center these, and we'll cut these down once we're done. Soldering iron, decent solder. I know a lot of people who tinker with cars have soldering irons and solder kicking around. You want a decent iron if you're doing this, and you want decent solder. Yes, this is a crusty, horrible old reel of solder on the outside. It's actually been properly kept, it's just been slightly battered. I'm using this because this is a leaded solder, so obviously you need to be careful, have the usual care about breathing fumes and handling it. You know, don't sit there fondling it and then go and dive into the biscuits or something like that. But it does take better onto used surfaces. It flows better. It's more durable, especially from a home user point of view, than the leaded solder. It's a lower temperature as well, so it's easier to work with. So what we're going to do now, to bring this back in, is flow solder onto all of these terminals just quickly. It should flow and take quite easily, as you can see. You don't want to keep heat on the plastic for any longer than possible. We'll just quickly test that these are all connected. Yep, yep, yep. That's all our grounds. Right, I would like, and I realise that I would like and I will get not the same thing, especially with the state of this desk. I was looking for tweezers, but I'm not going to get them. Just to make our life easier. Quick touch of solder onto each of these. There we go. Right, now what we need to do is get this in a position that you can work at easiest. For me, it's there. You don't get a lot of heat transference through them, so this is perfectly safe to do it this way. You can use tweezers. Just try and work out a way that you can see this. I'm going to use the wire cutters just because they're smaller than my fingers. There we go. So I think we could probably zoom in a bit as well. Focus, focus, come on. Could do with much better autofocuses on these cameras. Right, so LED goes in the centre of the hole, nicely lined up, and just quickly heat that solder again. And you're done. So we'll do the same again on the other ones. Into the middle. Heat the solder. Done. Don't be tempted to pull away as soon as it looks like the solder has solidified. Give it a few seconds. If you do pull away too soon, you might disturb the joint, and if you do disturb the joint, like I did just there, reheat it and start over. Don't be tempted to go, well, it's stuck, I'll leave it there. You'll get a cold solder joint, which is more likely to crack. Part of the reason that I'm having to do this one is because I've done this job on the one that's currently in my P38, and it's actually this one here that we're about to do has developed a cold solder joint, which means when it's lovely and cold in the morning, this display works a treat. Not so later on when everything's warmed up. Right, we don't need these anymore. Cut these tails off. Make sure you know where they're going, because if you don't, they'll end up inside. This one's a bit more difficult. It might have been prudent to do that one slightly differently. Let's zoom out a bit. Zoom, zoom, zoom. That Mazda advert is going to be in my head for years now. I've not heard it for the best part of 8 years. Right, we have 3 resistors there. I actually need 4, so we'll grab another one. Right, now if you were really clever and feeling quite brave, what you could do, let me grab a pointy stick, would be to go in between these. Now I have to zoom in because we can't really see a lot here. Zoom, zoom, zoom. Oh wow, that is taking forever to focus. There we go. Oh, no, I've gone too far the other way. There we go. I have no idea who Prayer is, by the way, before anyone asks. So what you could do here is you could quite easily get one of these little surface mount resistors in between here and here. It would be probably quite fiddly to do it. We're going to use through hole just because we can quite easily get it in there and feed across. So what we're going to do, I have just picked up all the resistors, is this resistor here needs to go from there to our new pin. Let's rotate. So I reckon trying to do this in a way that everything is kept nice and neat and tidy. So I reckon if we went in there like that and then brought that straight back on itself like so, we can probably get that in there nice and neatly. There we go, that's what we want, nice and neat. It's all away from everything. So let's just quickly, bit of solder on there. That's now stuck to my finger. Bit of solder there. And if we've got this right, that sits in there nice and neatly. You can see that that wire is now currently running straight over the other side, which we really don't want. So we give that just a little squeeze and bend it down, and trying to get an angle where you'd see this better. I don't think there is a way to get this any clearer. I'll just prop that up for a second. Stay. And then just where those two wires cross, a little blob of solder. And then we can now clip off that one, clip off that one, and just to make sure everything stays put, a little glob of hot snot. I need another stick in there. There we go. And we'll clip that off now as well. So there we go. This is what I meant about paying attention to where these offcuts go. You could quite happily reassemble that with that in there. So there we go. Where are we? I'm not sure I'm going to be able to zoom in much more than that, but we'll try. Focus. I need to find something with a faster focus. There we go. We're nearly there, nearly there, nearly there. There we are. So you've got your resistor from your positive side over to the positive side of the diode. The diode's grounded, and if we flip it over, where are you? Where have you gone? There's your diode just snuck in there. That will, in theory now, I won't say never fail, but it will certainly outlast any bulb. So I'm going to be quiet now. It's completely up to you whether you carry on watching or whether you fast forward a bit. But I'm going to zoom back out and hopefully focus. I'm going to do the other three, and you can either watch or fast forward on. I might even put some music in if I'm feeling nice. Last one. And there we go. Just have a quick look, make sure everything looks as good as it should do. And I'm just going to follow that trace back. So our 12 volt trace goes only onto here. So what we can do, somewhere around here, this bit, it's up to you whether you bother to do this. This is just me giving you a demonstration of how this looks. I would recommend you probably don't do this bit. Wait for it to be in the car before you test it. If only because I've got an idea of what I'm doing. I don't actually need this to work. If it doesn't work, I pull the other one out, I fix it. So our ground terminal is there. And follow that round. Our positive terminal is there. This is solely for you guys' benefit. And we will go and find a power source. Make sure our power source is turned on. And there we go. Obviously we've forgotten to do one at the moment. We could really do with doing the one in the middle. That's going to be slightly more tricky. They're cooler, it's better quality light, it will look better for it. I can't bring up the one on the display because that's powered up another way, so we'll leave that. But we need to work out how to do this one in here now. Quite frankly, if this display even works after this, I will be impressed. Let's just take these two test wires off. Now, where did that bulb actually sit? I will chuck it back in again. The other reason I don't really want to use this now is, I don't know if you can see, these are very loose without a bulb in there. So we'll work out where this bulb sits. That would be assuming the bulb even goes back in. So that bulb sits quite high. So I think we can dispense with that completely. So having managed to put it back in, let's take this ridiculous bulb holder out again. I believe this is slap bang in the middle of the lighting controls. Right, now the problem is we need our negative again. We know where they are on the top, so what we'll do is, that's our negative there, that's that pin. So we'll just draw around that pin there. If we can see that, sort of just. So we need to find our negative now on here. So we stick on there. That's our negative there. So we'll stick a black mark there. Now we were sitting a little bit higher. So we want to be about there, so that's almost flat. So if we bring that negative lead up fairly sharpish, the other risk with, certainly with this one, is there may be mechanical interference if we make it too long. So we'll do this one slightly differently to the others. We'll tin that. You're working on the PCB now, so this is a lot easier. And we'll actually cut this LED down before. Now, if we hold the LED from the back, you've got some bend in here, so if it's not perfect, don't worry about it too much. I would say get it as centered as possible. That's just gone horribly wrong. There we go. As I mentioned previously, if you disturb the joint, just do it again. Right, we need another LED. LED resistor. We're going to go up and down on this, so we're going to put a little hook on that there, and we're going to do the same as we did with the LED. We're going to cut that off now, and then if we hook it through the board so it comes through in the right place. I know that's just fallen off, so bit of solder there, clean the soldering iron bit, find the LED resistor. If you're holding on to these components while you're soldering them, just a word of warning, the LEDs take a while to heat up. These really don't. So through it goes. Onto the pad. Don't do as I've just done and trap your soldering iron underneath it. And that moved. There we go. Turn the board over again. You can see we've got two wires there. We want these two to meet as far down as we can. This is the point you want to adjust that LED, because once the LED is supported at 2 points, you've got next to no chance of doing anything with it. Quick double solder on the back. Can you see that? Sort of. There you go. And then cut the excess off. Don't cut it too close to your solder joint. That will cause you problems as well. And we'll hot snot it as well. Just give it a little bit of protection. We're done with that now. Right, so that's it. They're now all LED. All you would need to do now at this stage is to reassemble everything. Give everything a damn good clean. I will do that now. But if you've got this far, you've had it apart, you know how it all comes to pieces. There are no surprises in here. Just make sure that as you put it back together, everything is nice and clean. Here we go. I believe, if I remember correctly, you can actually individually assemble the temperature controls to make life a little bit easier. I don't think you can put the screws in though. These little stakes on these rubber mats just push directly behind them and they pop in. Yeah, if you tip that upside down to get it on, you're in for a world of hurt. Oh, also, there are these little ridges on here that prevent the light from the light from the buttons spilling into the display and vice versa. Come on. So there we go. That is pretty much it. I'll clean this now before it goes back in, and then hopefully for the weekend, I will have a heater control where I can actually see what's going on. That would be novel. I hope you enjoyed. I hope it's useful for you, and hopefully it'll save you some money. Bye.